Welcome class 10. Today we are going to learn about fuse. So what is an fuse? What is a fuse? An electric fuse is a device that is used to protect electric circuits and electric appliances against high current caused by short circuit or overloading due to excess withdrawal of large amount of current. So if there is by any chance, if there is excess current which flows through the wire, then this electric fuse uh, protects the appliances by melting the fuse wire. So in general, we have two types of fuses. The first type is called the plug fuse, that is connected just after the meter box, okay, before it reaches the other appliances. And the second type is cartridge fuses, which are most often found in most of the electrical appliances. So how does a fuse work? A fuse works on the heating effect of the current. So more the current will flow, more will be the heating effect on that wire. The wire will get heated up more if more current flows. Not only on current, but also the fuse wire gets heated up due to current and the radius of the wire. If the radius of the wire is quite small, okay, then more heat will be raised in that particular wire. If the radius is more, if the thickness of the wire is more, then the fuse wire will get heated up less. Okay, so we can say that del T, that is the heat, is directly proportional to I squared divided by R cube. So more the current flowing through, okay, it will the heat will depend on the amount of current which flows through, and also it is inversely proportional to the radius or thickness of the wire. A fuse is actually a piece of wire which has high resistance and very low melting point. So it needs to have a high resistance and low melting point. Why so? We will discuss about it. See, these are the fuse wires, okay, as they are made up of they are the alloy of lead and tin. Okay, so why it has low melting point is because if it has low melting point, then it can easily melt when excess current flows through it, and its melting point is almost about 250 degrees Celsius. And why it has high resistance is, it has high resistance so that it can produce sufficient heat to melt down when excess current flows through it. Okay, so if excess current flows through it, it has high resistance, so it gets heated up, and since it has low melting point, it will melt and it will break the circuit so that no current can flow through it. Okay, so copper or aluminum wire cannot be used as fuse wire because they have low resistance and high melting point. Their melting point is near about 1080 degrees Celsius. Since their melting point is quite high, so they cannot easily melt even if the current flows, high amount of current flows through them, so they cannot break the circuit. Okay, so here the purpose of the safety fuse is to break the circuit if excess amount of current flows. All right, now let's see how a fuse operates and how the fuse work. So this kind of fuse, which are called as plug fuse, okay, they have two parts. We can see over here, this part and this part. Okay, this part is called the socket, which remains fixed on a board, and the other one is called the plug, which can be removed easily. Okay, so the first one, the socket one, is fixed on a board, okay, on just below the meter board, or we can say on a particular board where it is fixed on a wall or a board. All right, and the other part, this one, can be removed or plugged in because it can be it can be removed, and we can put the fuse wire. If it is broken, then we can again plug it in, plug it back in on the socket. All right, this body is made up of porcelain. Now this porcelain does not conduct any electricity. All right, so porcelain, usually they are very bad conductor of electricity. That's why they are used as a body of fuse, so that there is no leakage of current. Now suppose there is a fuse, and this one, the socket part is on the board, and let's say there is a the first terminal, let's say the first terminal is T1 and the other terminal is T2. All right, this is T2, terminal 1 and terminal 2, and the terminal 1 has the connection from the meter. Okay, it comes over here, and terminal 2 has the connection which goes to the other appliances. Remember, this is supposed to be the live wire. Okay, so the live wire which carries the current comes from the meter, gets connected to first terminal T1, and there is no wire in between which can connect, and from T2 we have the other connection which goes to the other appliances of the house. Okay, so there is a gap between T1 and T2, so that current cannot flow directly from T1 to T2. Now what happens is, we put a fuse wire over here which is made up of an alloy of lead and tin. So this way a fuse wire is connected, and this fuse wire, now when this plug is put on to the socket, it will connect the electricity from this point to this point, from this point to this point. All right, from T1 to T2 it will connect, connect, and the current will flow from T1 to T2. All right, so we can see that a fuse, when it is ready, we can put it over here, and it connects the electrical appliances as the wire gets connected. Now by any chance, if there is any high flow of electric current, or if there is any short circuit, then this fuse wire will easily break. So let's say that this fuse wire is broken over here. Okay, now when it is broken, the current will not flow. This wire which comes from the meter, which is carrying the current, okay, now there is a breakage over here, so the current will not continue to flow from T1 to T2. So in that way, the appliances which are connected below this one, okay, the electrical appliances which are connected will not get that high amount of current, and it will not get damaged. And the next type of fuse is the cartridge fuse. The cartridge fuse are the fuses which are fixed on most of the electrical appliances like TV, inverters, televisions, air conditioners, refrigerators, etc. Okay, so these two parts are the metal caps which are connected with the circuit board, and the inside portion you have the fuse wire. Okay, so mainly these fuses are used in an electrical appliances on the live wire. Now let's understand why it is kept on the live wire. See over here, from the mains the live wire goes, and the fuse is connected out here, and this is the neutral wire. Okay, so the current goes from the live wire, reaches the appliances through the fuse. Okay, this is the symbol for the fuse, and when the work is done, the current again returns back from the neutral wire again to the mains. So this is the way any electrical appliances function. All right, so when the current flows, and if by chance there is a short circuit or anything goes wrong, and there is huge amount of current which flows through the live wire, the fuse will be broken. Okay, and once the fuse will be broken, this will be the condition. You can see that there is no connection of mains, the live wire, with the appliance. Okay, and this is only the neutral wire which is connected with the mains. Now by chance if you are touching the appliance first of all it will be safe. Okay, you if you touch the appliance by accident also, or when you if you try to plug it out, even at that point you will not get any electric shock, because the live wire which carries the current is not connected anymore. So in that way the appliance is safe and you can remove it safely. But in the second case, if the fuse is applied on the neutral wire, okay, then what happens? See over here, the fuse is connected with the neutral wire and the live wire is connected without any fuse to the appliance. And if by chance there is any short circuit or anything goes wrong, and if there is a huge flow of current through the live wire, then somehow let's say the fuse gets broken down. Okay, in this case you can see in this figure the fuse is broken. Okay, but the live wire is still connected with the appliance with the huge flow of current. Now if you want to remove this appliance, or if you touch the appliance by by accident, you may get an electric shock, because this appliance is still connected with the mains and the live wire where the huge amount of current is still flowing. Okay, only the neutral wire has been cut off because the fuse has been broken down over here, but there is no fuse connected, so over here the appliance still is connected with the mains. So actually this is a wrong way of connecting the fuse. So the actual way of connecting the fuse is this way. The fuse is always connected on the live wire, but if you connect the fuse on the neutral wire, then this may damage the appliance also, and it may also cause an accident. All right, so you need to be careful. If you are connecting the fuse, please don't connect it on the neutral wire. It is always safe to connect it on the live wire. On recent, on modern days, you can say on today's time, most of the fuse, the plug fuse, are replaced by this thing, which is known as MCB. MCB stands for miniature circuit breaker. Now, why the miniature circuit breaker is preferred over fuse is that the use of MCB is more convenient than a fuse. What happens? Let me explain. When the current, the live wire enters over here and the output goes from here, okay, and if anything goes wrong, this lever goes off automatically by itself. And if there is any faulty circuit, or if there is any huge amount of current flowing through the circuit, okay, any short circuit in the circuit, then this lever will go off automatically. And when everything is back to normal, when everything gets normal, a normal amount of current is flowing through, then again this lever gets on automatically by itself. Okay, this is why this MCB is preferred over use of a fuse. Okay, so the use of MCB is more convenient than a fuse because it is much safer due to its quick response. Now this response, the automatic shutting down or automatic connection getting on, is so quick that there is no need to replace the fuse wire, open the fuse wire, check the circuit. There is no need of doing so. But over here, if any short circuit is has happened, then you need to go and check. But over here, this lever will shut off or get off by itself. There is no need to pluck out the fuse as you do in the previous case. Okay, so first is it is much safer due to its quick response, and number two is there is no need of connecting a new fuse wire. If you are using a plug fuse, then in order to replace that fuse wire which is broken, you have to put a new fuse wire and again put the plug fuse and reconnect the entire thing. Okay, so over here there's no need of connecting a new fuse wire. So this is how MCB works, and it's quite easy to use MCB than using a normal fuse. Okay, and the cartridge fuse is still there in the appliances, which cannot be replaced by MCB. Okay, that is a different thing. So these are the uses of fuse and how it works. All right, so for your assignment you will prepare notes which has been done in this video. All right, thank you.